Okay, so let's look at chapter 2F, just the first example here. And up at the top, the only theorem we're going to deal with right now is this one, the complex conjugate zeros theorem. And it says if f of x is a polynomial and it all has real coefficients, and a plus bi is a zero of f of x, where b is not zero, so it's actually got an I term, then this is also a zero. The complex conjugate's also a zero. So like if I told you that you have some function and you know that 4 minus 2i is one of the zeros, then you also know that 4 plus 2i is going to be another zero. They come in pairs because of that quadratic formula. Remember, if we have the quadratic formula, it's negative b plus or minus square root b squared minus 4ac all over 2a. And if this thing turns out to give you an I, well then you've got the negative b plus the I and the negative b minus the I. So you've got the plus the I and you've got the minus the I version. Okay, so let's look at the example, and then I'm going to show you a website too that actually is pretty powerful if you haven't already seen it. So this one, we've got these zeros here, negative 3, 4, and 2 minus I, and this complex conjugate zeros theorem at the top of the page tells us if 2 minus I is a 0, then we know that 2 plus I also has to be a 0. And that's because we have the polynomial with real coefficients. I'm not going to give you any polynomials with imaginary coefficients, just so you know. So we need to write this polynomial in standard form, and it has to have minimum degree. So we don't want to throw in like extra zeros, just the minimum number of zeros that we need. So if I call the polynomial f of x, since negative 3 is one of the roots, it's going to be x plus 3. Since 4 is a root, we're going to get x minus 4. And then our complex non-real ones are going to be x minus, and then the first root, 2 minus I. And then x minus the second root, which is 2 plus I. And it's a standard form, so we've got to multiply all these things out. So let me multiply out first these two terms. So that one's not too bad. That's going to be x squared minus x minus 12. The second two terms, though, is a little bit worse because each one has 3 terms in it, really. So what I'm going to do is I'm going to just distribute the way that I normally would multiply 2 terms together, or 2 binomials together. So x times x is x squared, and then I've got x times this negative parentheses here. So it's minus x times that parentheses. Then I'm going to do these two terms, the x and the negative 2 minus negative parentheses 2 minus I and the x. So that's going to be minus an x times 2 minus I. And then I've got the last two terms, which are a negative and a negative, so it's going to be plus, and then 2 minus I, 2 plus I. So all that goes together. And so now let's work this out a little bit more. I'll leave the red part the same. I'm not going to touch that yet. And then the green part, I'll just distribute the simple stuff. So it's going to be minus 2x minus 2xi minus another 2x plus xi plus, and then this thing here is going to turn into 4. And then the 2i and the negative 2i will cancel, and then I'm just left with minus I squared. And remember, I squared is negative 1, so this whole thing turns into a plus 1. Plus 1 there. Okay, so let's simplify a little bit more. So I'm going to, again, leave the first thing the same. And then the second thing here, I'll simplify. So that's going to be x squared. The xi's cancel. Whoa. The xi's here cancel, and I'm left with minus 4x plus 5. So now I have to multiply these two trinomials together. So when I do that, this is where I tend to look for powers. If you like multiplying out every single thing, you can do that, but I tend to just look for, well, the biggest power I can get is x to the 4th, and there's only one way to get that. It's by multiplying the x squared times the x squared. Then the next biggest power is going to be an x cubed, and I can get that by multiplying this x squared. Ooh, I don't know what's jumping around. This x squared with this negative 4x, so I got negative 4x cubed. And I can also get it by multiplying this negative x times that x squared, which is going to be one more negative x cubed. So I'm going to get negative 5 of them total. Then I can get x squared terms. So the way I can get x squared terms is this x squared times this 5, so that's 5x squared. I could get this negative x times this negative 4x, so that's another 4x squared. Or I could do this negative 12 times this x squared, so that's minus 12x squared there. So that comes out to a total of negative 3x squared. So minus 3x squared. Let's see, now I got x terms to look at. So let me get another color here so I'm not, let's do blue. So x terms, I can multiply this negative x by that 5, so negative 5x's. And I can multiply this negative 12 times that negative 4x. So that would be 48 positive x's. So I'm left with negative 43 x's. So minus 43x. And then the units I can only get by doing the negative 12 times the 5, which is minus 60. So here is the polynomial in standard form. Oh, sorry, that's a plus 43. Forgot, this is positive 43, not negative. Now, these problems can get kind of gross, as you can tell. Lots of multiplication. There's a website that I want to show you. So if you ever have a homework problem like this, you can do this pretty quickly. It's called Wolfram Alpha. Wolfram Alpha, right here. And so what I'm going to do is I'm going to go to this website, and I'm just going to type in that original factored form. So it's x plus 3, x minus 4, x minus 2 minus I, and x minus 2 plus I. And then I'm going to hit enter, and it's going to calculate a little bit. And this is actually a really useful website. It also has an app available on iTunes, the App Store. That's what it is. And if you scroll down, it'll graph it. It'll graph it in a couple different ways, possibly. And then it'll give you all these different forms. It'll tell you the roots. It'll tell you the complex roots. It'll tell you, not that we know what the complex plane is yet. And then all this other stuff that's related to calculus down here. But it's a quick way of checking right here how you did. Okay? So that's that. Hope that helps.